welcome to Edison TV. I'm Vivian Parry, and today I'm talking to Bulent Altan, the CEO of Mynaric, a German-listed company founded in 2009 to commercialize wireless laser communication for aerospace. Now, Bulent is a SpaceX veteran, and we've asked him in for a chat because the US government is investing in a new network of reconnaissance satellites, EDSA, the National Defense Space Architecture. It's expected that this will have hundreds of relatively inexpensive low Earth orbit satellites, each deploying optical communications links. Now, Mynaric has already won a contract to supply those for the first phase of this project, and Edison believes that its focus on design for manufacture in volume and investment in capacity, as demonstrated by the recent opening of a new production hall near Munich, places it in a strong position to win follow-on business as the project ramps up. But what does Bulent think, and why? Well, we're about to find out. Bulent, welcome.
Thank you very much, Vivian. Nice to be here, and thank you for giving me the time.
First of all, ease us in gently with all of this. Can you explain why the Department of Defense is deploying laser communication links on the satellites in programs like the NDSA?
The laser communication has tremendous advantages, especially for crosslinks between satellites over regular radio technology. It's a complementary technology. Radio still has its place to play, but what laser communication allows in certain links is a point-to-point communication that is tremendously higher in bandwidth and a lot less power required. The power requirements when you want to send gigabits of data across, which in today's communication networks, even the governmental ones, are necessary. If you were to actually calculate them for such a radio link, it would be tremendous and unattainable for a satellite to generate on orbit. Yet laser technology, with its pinpoint accuracy, delivers all the power to the communication partner. So it allows tens, if not hundreds of gigabits to be sent over thousands of kilometers to the other side in the most efficient way.
So we've really reached a tipping point where we've got to the maximum capacity of radio, and this is the next frontier.
Absolutely. It is a technology that is for point-to-point communication. So if you were to cover an area on Earth, of course, you would still be using a radio technology. But for the point-to-point communication, such as is the case between two moving objects in space, that is the technology to have tens or if not hundreds of times the capacity versus the radio technology.
And can you explain why the interoperability of laser links is so very important?
I think it's a lesson learned by many of the MODs and the Department of Defense and many other organizations, governmental organizations around the world. We all know that supply chains and other drivers can be hit by things like COVID or by an earthquake, or for that matter, strategic decisions made by that company. So sole sourcing technologies and capabilities has been a troubled subject in the past in DoD acquisition. So they do want to, when they do want to do an acquisition within the DoD, within the different intelligence and governmental communities, they want to ensure that they have a technology where they can procure from a few vendors here, and then a couple of years later they can procure the same technology from another one, from another vendor. And when you think about also these constellations are constantly being deployed, it's not like they are deployed one at once and then they are a frozen constellation. They're always getting to be replenished by more launches. They get to be extended more launches by more satellites and technologies. And as those technologies and those satellites are deployed in orbit, the government wants to ensure that they can, at that point in time, make a free competition between available vendors and plug it into the existing network.
What about the contracts that you've already been awarded? Tell us a bit more about those.
So over the last year, we have announced that we have contracted with Telesat to launch satellites for the DARPA Blackjack constellation. And then we have also announced that we have won an additional governmental contract. Both were in the US. These contracts allowed us to put ourselves out on the open as a reliable vendor and a reliable partner for many satellite primes out there to deploy laser communication, not only for commercial, but also for government constellations. I think the government constellations and the contracts we've won are some of those lighthouse contracts, and commercial constellations do watch them very closely, who the government gives contracts to. And by the virtue of winning those two contracts, now we are seeing also movements in the commercial arena. We are already this year announced our groundbreaking deal with SpaceLink, and then right out under the heels of that, we have our MOU with the cloud constellation, and more such deals are definitely out in the way. We are working on them. So I think these early contracts have brought with it a tremendous amount of recognition and a seal of approval by the whole industry that Mynaric is a formidable vendor of laser communication, this groundbreaking technology.
And you've also opened your production facility. What's the capacity of that? Is that something like 2,000 devices?
Absolutely. We have made some great strides into our production. Production hall opening was definitely one of them, but there is many other steps. For example, hiring the right leadership in the production. For example, we hired Mr. Schultz from a commercial production line who does know how to do serial production and as our COO into Mynaric. And with these steps, we have been able to draw up plans and size up our production facility to target and achieve 2,000 terminals a year. And these terminals may be between air and space in any fashion. We may do more space or air, but we have written the number 2,000 in large letters into our production facility, and that's our aim.
Presumably, with this production facility in place, it really places you well to take share as the market grows.
Absolutely. I think the market is always going to grow. This is a technology just as it's in its breakthrough year. We have seen in the last year tens of laser communication terminals being bought. This year, it's going to be 4-digit numbers of laser comm terminals being acquired for the future. And as the demand grows, it's going to be companies like Mynaric that put a lot of emphasis, a lot of investment into serial production capability that will get the lion's share of the market, because our customers do not have time to give out contracts and then for factories to be built, then for the serial production plants to be made. They want to see from their vendors that they understand serial production, they take the necessary steps, make the right investments ahead of the contract award. And I think we stand as Mynaric as the company that has understood these steps and have made the right investments before such contract awards. One such contract award, we already know that the Space Development Agency in the US is going to award up to 150 satellites, each with up to 5 terminals on it. Just this summer, the RFP is going out this August, and the award is going to happen this year. It's going to be companies like Mynaric that have the capability to deliver that many terminals that are going to win big.
You're so enthusiastic about this, and I can see that this is now the herald of a complete change in the space industry. Why are we at this kind of inflection point where there's this rapid change coming?
So the space industry has been, I want to say, dormant in its mid years. I want to say, I think when we saw the space industry early on in its starts in the first half of the 20th century, all the way up to the end of 1960s, it was a very fast-moving industry with launches happening on east and west coast of the US all the time, Russia doing its things, and things were happening really fast. Then they got into a dormant stage where the strategic importance and the space race maybe took a little bit of a lower priority in the government, and then it took a more, I want to say, a political agenda, a job creation agenda. Yet at the start of 2000s, that changed again when commercial actors started to be interested in space. A really good example is SpaceX, where I worked for quite some time as an executive. It was the idea that such a dormant industry can benefit a lot from all the things we have learned in the rest of the world and its industries, such as commercial electronics in the .com arena, but also automotive, the serial production capabilities of the world, robotics, the 3D printing. Once commercial entities entered that arena, they started doing quick disruption, first with space launch. new rockets entered the play, and suddenly the access to space got democratized. And that was the most important step. Space would have never been a viable business if getting to space was expensive. And what used to be $25,000, $30,000 a kilogram to launch something into orbit is today $1,500 a kilogram, and price reduction 20x. So that's a fantastic enabler for the new space era. On the heels of that, people started experimenting with smaller and smaller satellites, incorporating terrestrial technology into their capabilities and launching those to orbit and getting real good successes, especially in the low Earth orbit. That is now moving everyone to what we call the new space economy. May it be commercial entities, and some of these entities didn't even have anything to do with space in the past, but now they're using their assets, and also the governments. A good example is that some commercial actors like John Deere are now interested in the space arena and what data they can get from there, increasing the efficiency of our farmland. Space today is no more for space purposes. It is a backbone, like the internet, like many other things. It is the backbone of our industry across different segments, and we're going to see that happening more and more in the future.
And when you talk about a tractor company getting into space, it really underlines the importance of this new arena. And as you say, it's a lot of those technologies coming back to Earth, as it were, that will give these companies really an added boost. People shouldn't just think of this as being full space only.
Absolutely. I think this is, I really do the parallels to what the internet did for every economy in the world. This is the same thing. This is like digitalization. It's going to penetrate every economy, every industry, every value chain that we know of, and it's going to be a big player. And we can imagine today, just we think about chief digitalization officers in every company. One of those CTO's jobs very soon may be a chief space utilization officer.
Thanks again, Bulent. It's a really fascinating area, isn't it? But we don't just take the company's perspective here at Edison. We really value getting that wider view. So I'm very pleased that we've got Anne Crow with us. Anne has recently written an update note. She's a technology analyst at Edison, and she's here to give us her view. Hello, Anne.
Hello, Vivian. And I'd just like to point out I'm actually one of quite a few technology analysts at Edison. But
I'm delighted to hear that there are so many top-class technology analysts at Edison. Just tell me, how significant is Mynaric's new production hall?
Well, as the poet John Donne said, no man's an island, and the same's true of companies. None of them work in isolation. So to appreciate the significance of Mynaric's production hall, you have to look at what the competition are or are not doing. If you look at the market, there's about half a dozen companies globally that are able to make the free space optical communication terminals suitable for satellites. And of these, there's two, and they've been awarded similar contracts to the one that Mynaric has to supply terminals for Tranche 0 of the Space Defence Agency contract. And there's a third, General Atomics, that's making 2 satellites and the terminals on board that will be used in a very preliminary trial phase of the program. So Mynaric's not alone. However, it is absolutely the only one that has announced it's opened a dedicated production hall with a production target of up to 2,000 terminals a year. And this is really important in the context of the SDA program, because the network that the SDA is planning is very different from anything that's gone on before. Historically, reconnaissance spy networks have relied on just a few really expensive, really complicated satellites. And so if hostile activity or a meteorite strike takes out one of those satellites, you've lost $1 billion in one go, and you've got a big hole in your network. So the SDA's new network is looking at a completely different way of building a satellite constellation to give you coverage, and it relies on having hundreds, in fact up to 1,000, of smaller, less expensive satellites connected together with optical communication links. And the SDA's made it really clear to companies wanting to partner with it on this project that they've got to change the way they do things. They've got to move away from the old style methodologies and adopt volume manufacturing techniques that will mean that they can supply satellites in the volumes needed, in the shortened timescales needed, and at the lower price points needed for this program. And I think for some of the older, more established satellite companies, that's going to be a bit of a culture shock. For Mynaric, not so much. It's one of the newcomers to the market, and it's been gearing itself up for volume production for several years.
So they really are very well placed. And also they've got a number of contracts, as you suggested, with the US government sector. Can you tell us just how significant those are, those of us who are not versed in American defence procurement policy?
Well, absolutely. I think, first of all, the monetary value of the contracts hasn't been disclosed, but we have inferred in one of our notes that the value to Mynaric of the SDA contract is in the mid 7-digit euro range. And if you think about it, that's just for supplying terminals to some of the 20 data relay satellites in Tranche 0 of the programme. And potentially there could be bigger contracts for, as the SDA starts to roll out the hundreds of satellites for Tranche 1 and Tranche 2. And clearly there's a risk that the SDA won't get the funding it needs to roll out Tranche 1 or Tranche 2. Tranche 2 is giving it the global coverage. But it does need that capability. It needs global information of threats, and it needs to get that information into the hands of the military as quickly as possible. So I think you can envisage a situation that if the US government wasn't going to get the funding it needed to build full coverage itself, it would work with some of the commercial broadband in the sky satellite providers, people like SpaceLink or Telesat, and kind of piggyback on that and make sure that the terminals on the commercial programs could communicate with the terminals on its own network, and it would get global coverage in that way. And so there's opportunity in that situation for Mynaric as well. I think Bulent's talked about the endorsement aspect. The other one that's of note is that the Blackjack DARPA program is scheduled